Hey everyone, welcome back to another TxePrep AIME/AMC video. And in this video, we're going to look over the 2018 AIME 2 question number 2. And the problem states, we're asked to find the sum of all positive integers b is less than 1000 such that 36 base b is a perfect square and 27 base b is the perfect cube. So first things first, whenever we have a base problem, what we want to do is convert it into base 10, so it's really easy to work with. So 36 base b can be rewritten as 3b plus 6, and 27 base b can be rewritten as 2b plus 7. And we know this must be a perfect square, and this over here must be a perfect cube. So we also know that 8 must be less than or equal to b, which is less than 1000. And the reason why b has a lower limit of 8 is simply because the largest digit in any of these numbers base b is 7, and it's impossible to have something like 27 base 7 or 27 base 6 because that's just not how bases work. So b must be at least 8. And now let's just list out all the potential bases that b can the perfect cubes that 27 base b can be. So that'd be something like 3 cubed, 4 cubed, 5 cubed, and we may say we run into a problem. We don't know when to end, but we can actually use the upper limit to help us find that. So when b is 1000, which is basically the maximum possible value, then 2b plus 7 will be the same thing as 2007. So all we need to do is find the perfect cubes that are less than 2007. And it turns out 12 cubed is the greatest perfect cube, which is less than 2007. So basically this list just goes on until 2007. And then cube. So we notice for one here that 2b plus 7 will always be an odd number, because 2 times any number will always be even, and an even plus an odd will always be odd. So that means we can get rid of all the even perfect squares. So it'll be 3 cubed, 5 cubed, 7 cubed, 9 cubed, and 11 cubed. And then we also notice that 3b plus 6 is divisible by 3. That means we can get rid of all of these things which are not divisible by 3, otherwise this thing won't be a perfect square over here. So all that's left now are 3 cubed and 9 cubed. So we just need to test if those two work. So 3 cubed and 9 cubed. So let's just set 3 cubed equal to 27, let 2b plus 7, and this is simply going to be b is equal to 10. And now when we plug it back into 3b plus 6, all we need to do is check if it's a perfect square. So 3 times 10 plus 6 is equal to 36, which is a well-known perfect square, meaning that one of our solutions is b is equal to 10. The other remaining option that we have is 9 cubed. And 9 cubed is simply 729. So now when we plug it into this equation over here, that's going to leave us 729 is equal to 2b plus 7. So 2b is going to be equal to 722, meaning that b is equal to 361. And now when we plug b into this perfect square over here, this is going to be the same thing as 361 times 3 plus 6. And 361 times 3 is simply just going to be 1083. Plus 6 is equal to 1089, which is also a perfect square, 33 squared, meaning that b is equal to 361 also works as a perfect square. So now all that's left is we're asked to find the sum of all these integers. So that must mean that the sum is equal to 361 plus 10, which is 371, which is our final answer.